Hi everyone, I'm Raya, and today me, Vicky, Dennis, and Elfine are going to present our project. So we will start with an introduction about our project, then we'll present a brief background, then the methods, results, and in the end, discussion. So starting with the introduction, our project's aim is to answer the following question. To what extent are the videos of the climate change MOOC clear? So for this purpose, we will analyze first video events, which include reduced playback speed, rewind and rewatches. Then we will look at incorrect answers to the questions following the videos. And lastly, video duration. So our assumption is that the relative number of incorrect answers characterizes the clarity of the video. Who will benefit from our project? So first, instructors, as they will be provided with insights that would allow them to have opportunities or think about ways to improve the online video learning experience. And as a result of that, students will also be benefited after the adjustments and improvements of the videos. So moving on to the background, what is already known in the literature? So first, we know that the use of videos in online courses is a highly effective educational tool and is being implemented in higher education in recent years, such as MOOC, online courses. We also know that video viewing behaviors, like reduced playback and rewinding the video, are part of clarity of the video. We actually followed Ido's paper that is currently under review from 2020. Okay, so now we'll move to the methods.
Coming to the method section, we are extracting the data from a climate change online course, which consists of 6 weeks data with 54 videos. Among the videos, only 34 videos have follow-up questions. The data was cleaned and organized from student ID based to per video based or per topic based. And we are still investigating more on the clean data. Let us introduce and define the video events. First, the rewind. In rewind, we are considering the video search event returning at least 5 seconds back. And second, the playback reduced. In playback reduced, the video playback speed reduced below 1. And third is rewatch. Students watch the video again on another day. Let's look into the data passing process for per video case. For each video, we arrange the data in the following order. First, course week, duration, the relative number of incorrect answers at first try to video associated questions, normalized by the total number of first try answers. And next, the relative number of each of the video events, normalization by the total number of students who watch the video. That is, the students at least play once. And next, the normalization by video duration for each of the video events. And next, the data parsing process for the per topic case. For each topic, we took the sum of the incorrect questions, rewinds, reduced playbacks, rewatches, and duration of all the videos in each topic. And then normalized by the average of students watched per video. Next, as in per video, normalized data based on total video duration. Now let us have a look into the rank-based data parsing process. For both cases, per video and per topic, we calculated rank by two methods. First, summing number of rewinds, reduced playbacks, and rewatches, which are normalized, and calculating rank without video duration. And second, the same process with considering the video duration. And next, the data analysis process. We have calculated the Gordon-Spearman correlations with relative number of incorrect answers, and each of the measures described at previous slides as we saw. For the rank evaluation, each group member will watch all the videos and we will rank its clarity with a range between 0 to 10. After that, we will compare it with the calculated ranks. This part we can show in the final report. Now let us go into the result section. First, the descriptive analysis part. Here we have plotted the normalized data to check if there is any general trend. Please note the x-axis is the course week and at which number of incorrect questions data are missing in the boxes shows. And we make some general observations here. For long video duration, the number of rewinds and the number of rewatches were more, and the number of speed reduce has negligible effect. Again, for long video duration, number of questions incorrect data were missing. That we noted here in the x-axis. For per topic case, except for first topic, all other topics almost have same total duration. Next, we can see the correlation results.
So for the correlation analysis, for the data organized per video, a positive correlation was found between the number of incorrect answers and the number of rewatches that was normalized using the total number of students who watched the video and the video duration. You can see a clear linear correlation. With a sample of 33, we've got a significant correlation with P of 0.008 average strength. What does this correlation mean? Totally makes sense. The more rewatches per unit of video duration there are, the more incorrect answers we get because the video is less clear. For the next one, a negative correlation between the video rank without taking into consideration the video duration and the number of incorrect answers was found. This one rather looks like a statistical fluke caused by low sample size. You can see visually that it can fit both a negative and a positive correlation. But we've got a Spearman test that showed significant correlation with P of 0.03, so we included it nevertheless. However, the moment we divide the video rank by the video duration, we get a clear correlation. You can see it here. The Spearman test gives the P of 0.02. It's a significant correlation. And if we do a Pearson test, we get an R of 0.56, which is rather strong. Sense-wise, it totally makes sense. The more rewinds and rewatches per unit of video length there are, the more incorrect answers we get because the video is less clear. As for the data organized per topic, we have a positive correlation between the number of rewatches normalized and the number of incorrect answers. As you can see, the Pearson test gives the P of 0.007 and the R of 0.68. It's a significant and rather strong correlation. Thank you.
Hi, my name is Vicky, and now we'll discuss the result. We saw that the number of rewatches is correlated to the increase of incorrect answers, both in per topic and in per video analysis. To remind you, the rewatch event was defined by watching the video again in another day. This course also has graded quizzes, assignments, and exams. So one possible explanation is that the video was not clear enough and they watched it again before the quiz, assignment, or exam. Despite the similarity of results in different videos representation per video and per topic, we saw that for the per video analysis, the significant result was only obtained with normalization of the video duration. As we saw from the descriptive analysis, there was more variation of the video duration. So the number of video events are more sensitive to the video duration in the per video representation. We received another significant result when we analyzed correlation with the calculated rank for each video. We received two opposite results: a negative correlation with rank that was not normalized by video duration, and positive correlation when it was normalized by video duration. Those results not really make sense. We assume that the negative correlation can be due to small data effect. It may be a small number of samples that doesn't allow a certain correlation. Let's go back to the graph. You can see in the graph that the direction is not clear. It can be negative, but it also can be positive. You can see in another rank with the video duration normalization that the direction is only positive direction. So I just want to remind you, the rank is combination of the three videos events: rewind, rewatch, and playback speed reduction. It is possible that the significant positive correlation is due to the number of rewatches, because we already saw it association with the number of incorrect answers. We need further investigate with another test, for example, linear regression. We still have more work on this project. First, data cleaning. Although the information has been cleaned, we have seen a number of events that require further investigation. We want also to watch all the course video, rank them, each group member separately, and then compare the results to the calculated ranks. We also saw that there are bad videos that are shallow, and the question of clarity is not relevant for them. For example, very short videos representing only the follow-up question. We want to find all of them and exclude them when we analyze the correlation per video. The last one is the rank investigation, as I mentioned in the previous slide. Just a point to mention, if it was a bigger research project, we think that the best way to define the clarity of the video is not from the associated questions, but more from student opinion. We think that from two reasons. First, not all the questions are related to the specific video they are associated with. Second, not all the videos as a follow-up question, so it eliminates a lot of data. 20 videos were excluded, around 40% of the data. Thank you.
Thank you so much for your attention, and we'll be happy to answer your questions.